Good morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss a very important topic in probability in statistics. It is, we are doing some problems on Poisson distribution. Already we are much aware about Poisson distribution. When do we use Poisson distribution? When if binomial distribution n goes for infinite value, then it approaches to Poisson distribution. If in binomial distribution, actually, if it takes very larger values, then it goes very closer to normal distribution. But binomial, here one thing we have to know about here, that is binomial distribution and Poisson distribution, they are varied for discrete random variable, whereas normal distribution is for continuous random variable. So, Poisson distribution is a special case whenever the rate of measure is sufficient, and when n tends to infinite value, then optically we use Poisson distribution. So in Poisson distribution, we will find very accurate value than binomial distribution, and it is specified and reasonable. Suppose sometimes same sum we may do in a binomial distribution, we may find its value using Poisson distribution also, but there will be no that much difference. Just within fourth decimal or fifth decimal, a slight change may come. It is negligible. We need not serious about it. First 3 digits will be significantly same. In fourth or fifth digit for decimal, especially in fourth or fifth decimal, it may a slight change will be there. Instead of 2, some 6, instead of 3, some 7. It may not be in fourth decimal. That much change is very infinite small. It is negligible. So that's why the finding values by using binomial distribution and Poisson distribution is significantly, and it is valid and arithmetic, and we can admit those values with a very slight difference. That slight difference is very negligible. So in Poisson distribution, this distribution has widespread applications. For example, in analyzing traffic flow, in fault prediction on electric cables, and in the prediction of randomly occurring accidents. Here, why do we use Poisson distribution? See, in a busy road, suppose that road is not at all good in condition. Suppose per day 1 or 2 accidents randomly it is going on, but next day may not occur. But that next day also may not occur. After the next day it may occur. So that's why sometimes it may occur, sometimes it may not occur. So such type of situation comes under Poisson distribution. In binomial distribution, continuity will be there. In Poisson distribution, random in between some discontinuity will be there, but the possibility of occurrence can be calculated correctly. That's why that is the main significance of Poisson distribution. Here, whatever we have discussed here, all these come under these cases only. Traffic flow, the same road. So some days, one day it may be very clean. Other day it may be with a very heavy flow. Other day it may be with a medium flow. So it depends upon the time, that day. Suppose any great event is there in that city, all roads will be blocked, all roads will be very traffic highly, that they will be flow. So like that, it depends upon the situation also. Like that, prediction on electric cables. See, electric cables, some cables may be good at condition. Randomly out of 1000 or 2000, at least 2 or 3 cables may not work out properly. So such type of prediction also we can find with utmost value, correct value. So we shall look at the Poisson distribution in two distinct ways. Firstly, as a distribution in its own right, this will enable us to apply statistical methods to set of problems which cannot be solved using the binomial distribution. That's what we are choosing Poisson distribution. Secondly, as an approximation to the binomial distribution, X maps to binomial of variables n and p, where n is number of trials, p is success probability. In the case where n is large and p is small, then we use binomial distribution there. Here we will find that this approximation can often save the need to do much tedious arithmetic. Now, already we know in previous cases the Poisson distribution formula. Poisson distribution is actually another probability distribution formula. As per binomial distribution, we won't be given the number of trials or the probability of success on a certain trial. Where in binomial distribution, number of trials and success probability P we talk about there. And in that also special case is the N is too large and P is too small. Here we define this Poisson distribution using the average number of successes parameter, that is denoted by Greek letter lambda. Here that lambda is average number of successes. So the formula for Poisson distribution is P of some x is equal to some random variable, some x is defined as e to the power minus lambda, average number of success, minus lambda into lambda to the power x divided by x factorial. Here x is the average number. Here lambda is the average number. Lambda is average number, the rate of average number. X is a Poisson random variable. E is the base of logarithm. It is Euler's value. It is 2.71828 approximately. So let us see some interesting problems depending on Poisson distribution. As only 3 students came to attend the class today, find the probability for exactly 4 students to attend the classes tomorrow. This is just a simple question. Today, suppose it is some rare class, some design coursing class or whatever it may be, number of students will be less. Automatically, they will become 4, 5, 6 like that, because they are practical oriented classes. So limited number of classes, limited number of persons will be there. Suppose for that class today 3 students were attended. Then what they are asking, find the probability for the same class for exactly 4 students to attend the class tomorrow. They are asking. Today 3 are attended. Tomorrow let us find the probability to attend for 4 students. For that, our Poisson distribution is the correct model, correct procedure, correct model to deal this. Here, the average rate of value is 3 is given here. Now, Poisson random variable according to the sum is x is equal to 4. Now, Poisson distribution here, success rate is 3. And Poisson distribution, they are asking for x is equal to 4. So here P of, according to the formula, what is P of x is equal to x is equal to e power minus lambda into lambda to the power x by x factorial. It is known to us. E to the power minus lambda into lambda to the power x by x factorial is known to us. This is P of x is equal to x is equal. Now we we need for P of x is equal to 4. Then it will become P power minus lambda into lambda power x means 4 by x factorial means 4 factorial. Then it's here lambda value is 3. So instead of lambda, let us keep 3. Now e power minus 3 value from logarithmic tables, from exponential tables, we can find out. Here lambda value we know 3. So 3 to the power 4 is 81. You take e power minus 3 value from tables. 3 power 4 is 81. 4 factorial. 1 into 2 into 3 into 4 how much? 24. So all are known to us. So after simplification, this value is coming as 0.16803135574154. We may take up the first 4 digits. So like that, we can estimate, we can find the probability. Now let us see very interesting sum. Actually, this sum is given as a very big one, but if you catch the central idea, the point, then it comes in within only 2 or 3 steps. Here, what is given there? We introduce the binomial distribution by considering the following scenario. A one machine is known to produce 10% defective components. Here 10% defective components means 0. Here defective components you have to take it as success probability. Then success probability it comes under 0.1. But see, it is after that some more is given, then only you have to judge whether this has to be taken as success probability or next one has to be taken as success probability. Next, continue. If the random variable x is the number of defective components produced in a run of 3 components, find the probabilities that x takes the values 0 to 3. So you have to find P of 0, P of 1, P of 2, P of 3. P of x is equal to 0, P of x is equal to 1, P of x is equal to 2, P of x is equal to 3. You have to find. Suppose now that a similar machine which is known to produce 1% defective components, that's what here you have to take this 1% as defective components as probability of success. So that's why here that P, if you take it as 1% means 0.01. So since this is the defective, you have to take it as Q. So Q is judged as 0.01. Then what will be P? 1 minus Q. Here P will be 1 minus Q. So 1 minus 0.01. It is 0.99. Like that we have to find success probability P. By reading the sum only, we have to analyze all these parameters. Then let us keep them in formula. The two defective items are produced. That's why R is equal to 2. That's why you have to read the sum properly. Whatever information is given there, you have to catch it out. You have to keep it as a raw material here. What is what? In our terminology, what is P? What is Q? What is R? What is X? All are given there only. We are not taking from anywhere. Everything is given in the sum. You have to read the sum properly, and whatever given there, you have to pick it out, and you have to keep that every matter here and keep it ready and substitute in formula. Here 2 defective items are produced. That's why R is equal to 2. Essentially, we are assuming that X maps B of 40, 0.01 means 40 is n value. small n is equal to 40. Like that, whatever sum you do, first of all, read the sum properly. Whatever hidden matter is there, whatever hidden terminology is there, whatever mathematical terms are there, you have to take their values like this. You have to analyze like this. What is Q, what is P, what is R, what is N. Everything is given there only. Pick it out. They are asking for P of X is equal to 2. Means two defective components for the probability to take out two defective components they are asking now. We use both the binomial distribution and its Poisson approximation for comparison. Means they are asking us to find out this value using binomial distribution and Poisson distribution also. Okay, let us do. Now let us do in a binomial distribution. Every matter, already whatever terminology is needed here, everything we kept it ready. Now using the binomial distribution, we have the solution. P of what they are asking for two defective bulbs they are asking, two defective elements they are asking. So P of X is equal to 2. Keep it in formula. NCR P to the power n minus R into Q to the power R. Keep it in that formula. NCR, N is 40, C, R is 2. So 40 C2 into P to the P is what? 0.99 to the power n minus R means 40 minus 2 into Q to the power R. What is Q? 0.01 to the power R 2. After simplification, it comes as 0.0532. Same sum, let us do using Poisson distribution. Here, what is lambda here? 40% they're asking success rate of success 40. So that we have to take it as a lambda here. Actually, to find lambda, we have the value n into p. Here n value is 40 into p value is 0.99. So since 0.99 is very much nearer to 1, we take it as 1 and 40 because lambda is parameter, success rate parameter. That's why infinitely, nearly its value we round it off and lambda we take it as 40. Then here 40% is means 0.4 in our terminology. So P of X is equal to, now use a Poisson distribution formula. E power minus lambda into means e power minus lambda means 0. Lambda means 0.4. So e power minus lambda into lambda to the power and 0.4 to the power x. X is here 2. R is nothing but x in Poisson distribution 2. So after simplification, it is coming as 0.0536. Compare these two values. Up to 0.053 same. In fourth decimal, here 2 is there, here 6 is there. It is negligible, infinitesimally small. Almost both two values are exactly nearly equal. Nearly they are equal. Only slight difference, that is 0.00004. It is infinitesimal, negligible. But very significance is there for both the values. That's why here we can note that the arithmetic involved is simpler and the approximate is reasonable. Here, in comparison with the binomial distribution, here in Poisson distribution, calculation is very easy. And within one step, the answer has come. And whatever answer you got in Poisson distribution is very, very close to the answer what you have got in binomial distribution. That is the use of Poisson distribution. So in Poisson distribution, in quick time, in less time than binomial distribution, we can find the probability in a very quick time. Like that, let us see one more example. Mass produced needles are packed in boxes of 1000. Means 1000 needles, one box. 1000 needles, one more box. Like that, in each box, 1000 needles we are packing. It is believed that one needle in 2000 on average is substandard. Means it is not that much qualitative. What is the probability that a box contains two or more defectives? Means P of X greater than or equal to 2 we have to find. Here what we have to find? P of X greater than or equal to 2 we have to find. 2 or more means P of X greater than or equal to 2 we have to find. The correct model is the binomial distribution with n is equal to 1000, p is equal to 1 by 2000 and q is equal to 999 by 2000. Here n is given as 1000, p is given as 1 by 2000, q is given as 1999 by 2000. Now everything is known to us. They are asking now that's why first of all they are asking P of X greater than or equal to 2. That's why this can be easily we can do like this. P of X greater than or equal to 2 means what? From 1 you have to subtract P of X less than 2. Less than or equal to 2 means less than 2 means what will they come? Two cases will come. P of X is equal to 0 and P of X is equal to 1. Those two you add and subtract from 1. This you will get P of X greater than or equal to 2. Simple method. That's why you find P of X is equal to 0. P of X is equal to 0 means there is no success probability. Only failure probability is there. Failure probability is 1999 by 2000. So its power n. So 1999 by 2000 to the power 1000, its value is 0.60645. Next, P of X is equal to 1, let us find. Use formula. NCR 1000 C R is 1. NC1 means n means 1000. 1000 C1 means 1000 into P to the power. P means 1999 by 2000 to the power n minus R. 1000 minus 1. It is 999 into R 1 by 2000. So it is Q to the power R. So here P 1 by 2000 is Q. This is P. So it becomes 1 by 2 into 1999 by 2000 to the power 999. Its value is 0.30338. Now what we have to do? We have to add this value and this value, and that sum has to be subtracted from 1. Then we will get this P of X greater than or equal to 2. That's why now we are adding P of X is equal to 0 and P of X is equal to 1. It is 0.9098. Now we subtracted it from 1, we will get our required answer. Hence P of 2 or more defective means P of X greater than or equal to 2 is equal to 1 minus sum of these two, 0.9098 It is 0.0902. It is the probability that a box contains two or more defectives. So, probability of box contains two or more defectives is equal to 0.0902. That is what they asked us. Now let us see one more sum. In the manufacture of glassware, bubbles can occur in the glass which reduces the status of the glassware to that of a second. So in a bubbles means what? In a fraction of second they will merge out. They vanish. That's why parameter second has taken. If on average 1 in every 1000 items produced has a bubble, calculate the probability that exactly 6 items, here x value 6, exactly 6 items in a batch of 3000 are seconds. Now 3000 are seconds means n is equal to 3000 given. P value, see here p value is very much less than 0.005. It is p value is equal to 0.001. How? See, for 1000 items, one in every 1000 items produced as a bubble. So 1 by 1000. 1 by 1000 means what? 0.001. That it comes as P. It is much less than 0.005. Because our level of significance we have discussed in a test of hypothesis. In that it is less than 5% distribution, 5% level of significance. Here, let us suppose that x is equal to number of items with bubbles. Then x maps from B 3000 to 0.001. Since n is equal to 3000, which is greater than 100, and p is equal to 0.001, which is less than 0.005, we can use the Poisson distribution with lambda is equal to n into p. N value is, here we can find lambda value using the formula n into p. N value is 3000, p value is 0.001, so its value is 3. So lambda rate of success is 3 here. Like that we found directly or indirectly lambda value 3. Now they are asking for x is equal to 6, exactly 6 items they are asking. Now we have to find p of x is equal to 6. We have to find p of x is equal to 6. It is e to the power minus lambda. Lambda value is 3 into lambda power x means 3 to the power x value 6 by x factorial means 6 factorial. After simplification, it comes very nearer to 0.05. So the result means that we have about a 5% chance of 0.05 means 5% chance of finding exactly 6 seconds in a batch of 3000 items of glassware. So our answer is very exactly 5%. Like that, let us see one more interesting sum. A manufacturer produces light bulbs that are packed into boxes of 100, 100, 100 like that. If quality control studies indicate that 0.5% of the light bulbs produced are defective, what percentage of the boxes will contain? Two questions they are asking. No defective bulbs, and one more question, two or more defectives. So here in our probability terminology, what we have to find? For A, we have to find P of x is equal to 0, no defective. And for B, second question, what we have to find? Two or more defectives. For that, what we have to find? P of x greater than or equal to 2. These two things we have to find now. So, as n is large and P, the P defective bulb is small, use the Poisson approximation to the binomial probability distribution. If x is equal to number of defective bulbs in a box, then x maps to P of mu, where mu is equal to n into P. 100 into 0.005, it is 0.5. So, let us find our values. P of x is equal to 0 is equal to, under Poisson distribution, e power minus lambda means e power minus 0.05 into lambda to the power x means 0.5 to the power x value is 0 here by 0 factorial. It is coming very nearer to 61%. 0.6065 means nearly 61%. Now let us find P of x is equal to 2. P of x is equal to 2 or more they are asking. It means P of x greater than or equal to 2. Same previous technique let us use. P of x greater than or equal to 2 is nothing but P of x greater than or equal to 2 is nothing but 1 minus P of x less than 2. Let us use this technique. Our calculation steps will be less. Within a short span of time, you will get your answer. P of x greater than or equal to means so many things will come. 2, 3, 4, 5, etc. Up to 100 you have to go. All those values can you find? It takes much time. So instead of doing that, use this technique. P of x greater than or equal to 2 is nothing but 1 minus P of x less than 2. So, for that P of x less than 2, two cases are possible. P of x is equal to 0, P of x is equal to 1. Find those two and add them and subtract from 1, you will get your answer. P of x greater than or equal to 2. So, P of x greater than or equal to, using that technique, we can find it as 0.3033. So, P of x greater than or equal to 2 is 1 minus sum of these two is coming as 0.0902. It is nearly 9%. Now let us see one more interesting sum. It is a very small sum but very much interesting. Let us see. Calculate the value for P of x is equal to 6 to extend the table in the previous task using the recurrence relation and the value for P of x is equal to 5. It is related to the previous sum. In the previous sum, if you find P of x is equal to 5 and P of x is equal to 6, one recurrence relation will come. That means the relation between those two will come as P of x is equal to 6 is equal to 2 by 6 or 1 by 3 times of P of x is equal to 5. This is not true for all. This is the sum. This is the recurring relation which came for previous one. For that only it is true. It is not at all true for all. That relating to that sum only this question had been asked. So already one sum, previous sum we did know, from that relation we are taking. This question also is asking on that only. That's why in that we substitute. P of x is equal to 6 is equal to 1 by 3 into P of x is equal to 5 we calculated there previously. 0.0361. Simplify, it is coming as 0.0120. It is nearly 1%. Let us see one more important sum. Suppose it has been observed that on average 180 cars per hour pass a specified point on a particular road in the morning rush hour. Due to impending road works, it is estimated that congestion will occur closer to the city center if more than 5 cars, means P of x greater than or equal to 5, we have to find more than 5 cars. P of x greater than, strictly P of x greater than 5, we have to find. Pass the point in any 1 minute. Here, first one, 180 cars per hour is given. 180, we have to catch the point. 180 cars per hour. So, per minute, how many cars will go? 180 by, in 1 hour, how many minutes are there? 60. So, 61, 63. So, in 1 minute, how many cars will pass through? 3 cars. That's why lambda value, you have to take it as 3. That's why from the beginning I am telling, read the sum carefully. In the given sum only, all the matter will be there. Whatever we need the values, whatever we need parameters, everything will be hidden in that sum only. So, read the sum carefully and catch it out. Pick it out. What are the values hidden there? Take it out. Keep it on paper. Use it in our formula. That is the technique. So, 180 cars per hour means 3 cars per minute. Like that you have to translate. You pass a specified point on a particular road in the morning rush hour. Due to impending road works, it is estimated that congestion will occur closer to the city center. If more than 5 cars, means what you have to find? P of x greater than 5, you have to find. Per minute already we found there. That value becomes as lambda. Lambda is equal to 3 here. So what is the probability of congestion occurring? They are asking. Now let us try to understand. Here we note that we cannot use the binomial model since we have no values of n and p. We don't know total number of trials. We don't know success probability. So there is no question of applying binomial model. Essentially, we are saying that there is no fixed number n of cars passing the specified point. We don't know. And that we have no way of estimating p. No chance. The only information available is the average rate. Lambda. That average rate is nothing but lambda. Here, average rate, it is our lambda. We know. That is also indirectly we know. That 180 by 60, that is 3. At which car passes the specified point. Let x be the random variable. X is equal to number of cars arriving in any minute. We need to calculate the probability that more than 5 cars means P of x greater than 5. We have to find it now in 1 minute. Note that in order to do this, we need to convert the information like this, given an average rate, lambda is equal to 3. So using lambda is equal to 3, let us calculate the required probabilities like this. R, P of x is equal to R. If R is equal to 0, we can find using that formula e power minus lambda into lambda power x by x factorial. Like that, using that formula, for x is equal to 0, its probability is 0.04979. If x is equal to 1, its probability is 0.149361. If x is equal to 2, its probability is 0.22404. If x is equal to 3, its probability is 0.22404. If x is equal to 4, its probability is 0.168031. If x is equal to 5, its probability is 0.10082. And let us add there all these probabilities. It is coming as 0.91608. How these values come? From where do they come? They came from this formula, e power minus lambda into lambda power x by x factorial, where x stands from 0, 1, 2, 3, 4, 5. So in that formula, we use those values and simplify. We are getting these values. So now we want p of x greater than 5. We want p of x greater than 5. Means so many things will come. P of x is equal to 6, x is equal to 7, x is equal to 8, like that. So many will come. All those things can we find? We cannot find. Use technique. It is this p of x greater than 5 is nothing but 1 minus p of x less than or equal to 5. Then automatically it will become p of x greater than 5. See, we have to make it easy. We have to make it simpler. Don't make it complicated. If whatever available information is there, we have to use it efficiently. We have to use it conveniently and suitably. We have to use in our strategy and make the sum simpler. So p of x greater than 5 is nothing but 1 minus p of x less than or equal to 5. Then our problem will be easy. P of x greater than 5. That means they are asking in that center passing more than 5 cars in 1 minute they are asking. So p of x greater than 5 is equal to 1 minus p of x less than or equal to 5. So using that we are getting its value is 0.0839, means it is nearly 8%. If you want to say in percentage, it is that probability that p of x greater than or equal to greater than 5. P of x greater than 5 is nearly 8%. Let us see one more important sum. The mean number of bacteria per milliliter of a liquid is known to be 6. Means here, what is lambda? Lambda value is 6. So by reading the sum, immediately we have to keep the matter here. By reading the sum, immediately we have to take whatever our required terminology, mathematical terminology is there, we have to assemble here. We have to gather it here. Find the probability that in 1 milliliter of the liquid, there will be 0 bacteria, 1 bacteria, 2 bacteria, 3 bacteria, less than 4 bacteria, 6 bacteria. Those probabilities we have to find. Here we have an average rate of occurrences but no estimate of the probability. So it looks as though we have a Poisson distribution with lambda is equal to 6. Using the formula in key point 7, let us find one by one. A, 0 bacteria means p of x is equal to 0. Using formula e power minus lambda, e power minus 6 into lambda power x, 6 power 0 by x factorial, 0 factorial. It is 0.00248. Next, p of Uh, B question. One bacterial, probability per one bacteria, they are asking. Means P of x is equal to 1, we have to find. Keep it in our formula, it is coming as 0.0149. Like that. Yeah, P of x is equal to 0 means what? That is the probability having no bacteria in 1 ml of liquid is 0.00248. Like that, P of x is equal to 1. We found it as 0.0149. Means what? The probability of having one bacteria in 1 ml of liquid is 0.0149. Like that, find P of x is equal to 2. It is 0.0446 here. Means the probability of having 2 bacteria in 1 ml of liquid is 0.0446. Like that, find 3 bacteria. Means P of x is equal to 3. It is coming as 0.0892. Means what? The probability of having 3 bacteria in 1 ml of 1 milliliter of liquid is 0.0892. Now they are asking less than 4 bacteria. Means P of x less than 4 we have to find. So P of x less than 4 means what? P of x is equal to 0, P of x is equal to 1, P of x is equal to 2, P of x is equal to 3. These 4 cases will come, we have to add them. P of x less than 4 means P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3. All these are available here, add them. It is 0.1512. Now the last question they are asking, x is equal to 6, P of x is equal to 6. Keep it in formula, e power minus lambda, e power minus 6 into lambda power x means 6 power 6 by x factorial, 6 factorial. It is 0.1606. Like that, whatever they asked, all those questions we have successfully answered here. Here, in working out in first 6 answers, which link together, all the digits were kept in the calculator to ensure accuracy. Answers were rounded off only when written down. Never copy down answers correct to say 4 decimal places and then for each one individually don't round it off. After finding the whole answer, then totally for lastly you round it off. For each and every step, if you round it off, there will be much significance of difference in last. That's why for every step, for every each answer, don't round it off. So if we round it off the errors, here we are getting answers 0.0025, 0.0150, 0.0450, 0.9000, and P of x less than 4 is 0.1525. The difference is not great but could be significant. That's why individually don't round it off. After finding the total answer, you round it off. Now let us see one more important sum. A council is considering whether to base a recovery vehicle on a stretch of road to help clear incidents as quickly as possible. The road concerned carries over 5,000 vehicles during the peak rush hour period. So here what is given here we have to estimate properly. 5,000 vehicles during the peak rush hour period. These are 5,000 vehicles per hour. Records show that on average the number of incidents during the morning rush hour is 5. So this is our lambda. The council won't base a vehicle on the road if the probability of having more than 5 incidents means P of x greater than 5 in any one morning is less than 30%. So here everything is given, just we have to keep it in our form and keep it in formula, substitute and find out the answer. Based on this information, should the council provide a vehicle? So after finding the probability, we have to judge for that purpose the council should provide a vehicle or not. We can judge after finding this probability. Here we need to calculate the probability that more than 5 incidents occur, that is P of X greater than 5. That what is that vehicle? Clearing vehicle, the traffic clearance vehicles. So if more accidents are occurring in that on that road every day, what will they do? Immediately they will send this type of traffic clearance vehicles, and they will make the traffic smooth and take appropriate measures to take things not to happen such things again and again. So here the for that what is helpful to us, the accident occurring probability will judge us whether council has to take action or not, they have to send vehicle or not. Here P of, let us find P of X is equal to 5. Here morning rush hour, five vehicles on the road and the 5 incidents are going on. So here number of incidents 5. That is why X is equal to 5 you have to take. So when P of X is equal to R is equal to e to the power minus lambda. Lambda value already I told you it is coming 5. It is given in the sum only. During the morning rush hour is 5. So this is only our lambda. So we have to find the fact of P of X greater than 5. Means the probability of occurring accidents more than 5 on that road we have to find. For that, first you find is equal to 5. P of X is equal to 5. It is e to the power minus 5 into 5 to the power r by r factorial. Now let us find one by one. P of X is equal to 0. Using that formula e power minus lambda into lambda power x by x factorial, it is coming as 0.00674. Like that you find P of X is equal to 1. It is coming as 0.3369. Like that you find P of X is equal to 2. It is 0.08422. Like that P of X is equal to 3. 0.14037. Like that P of X is equal to 4. 0.17547. Like that P of X is equal to 5. 0.17547. Now our required matter has come. What we have to find? P of X less than or equal to 5 we have to find. Means add all those things. P of X is equal to 0, P of X is equal to 1, P of X is equal to 0 plus, P of X is equal to 1 plus, P of X is equal to 2 plus, P of X is equal to 3 plus, P of X is equal to 4 plus, P of X is equal to 5. Add them. It is coming as 0.61596. Now our answer has come. What do we need here? P of X greater than 5 we need. Further it is nothing but 1 minus P of X less than or equal to 5. So from 1 this value you subtract. Our purpose served. The probability of more than 5 incidents, that is P of X greater than 5, is equal to 1 minus P of X less than or equal to 5. It is 1 minus 0.61596. It is approximate. It is equal to 0.38403. it is nearly equal to, it is nearly 39%. So 39% means it is not a easy thing. Accidents are going on. So the council has to send the vehicle. So it is not a silly thing. They cannot see, they cannot leave it as easy thing, silly thing. They cannot take it as a small thing. 39% means more accidents are going. There is a probability to happen more accidents. That's why the council has to take action. The council has to send the road clearance vehicle. Like that, we have to judge. So, if X is the random variable, number of occurrences in a given interval, for which the average rate of occurrences is lambda, and X can assume the values 0, 1, 2, 3, etc. and so on, and the probability of R occurrences in that interval is given by P of X is equal to R is e power minus lambda into lambda power R by R factorial. All these sums we used using this formula. Then the expectation and the variance, already we have discussed this. The expectation and the variance of the distribution are given by the formula expectation of X is equal to lambda and variance of X is equal to lambda. That's why in Poisson distribution, expectation is same as variance. Both are equal. In Poisson distribution, expectation and variance are equal. Let us see one more important sum. Large sheets of metal have faults in random positions, but on average have one fault per square meter, 10 square meters. It is 10 square meters. What is the probability that a sheet 5 meter by 8 meter means 5 meters length, 8 meters breadth will have at most one fault. At most is very important. At most one fault means here at most, that's why I am giving much significance here. At most one means we have to find P of X less than or equal to 1. At maximum 1 and below that only. It cannot come more than 1. That is at most. Here, at most 1 means up to 1 mistake may loophole may come, but it should not exceed 1. Below that much and below that. That is called at most. At most 1 means P of X less than or equal to 1 we have to find. So it comes under Poisson distribution case. So Poisson process in a sheet size 40 square meter, 8 into 5 length into breadth, 8 into 5 40 square meter rectangular sheet. Area of rectangle is equal to L into B. Length into breadth, 8 meter into 5 meter, 40 square meter. So that rectangular sheet here size it is 40 square meter. We expect to so for every square meter one fault they are giving. In sum it is given, but on average have one fault per 10 square meter. For 10 square meter one fault. Like that for 40 square meters 4 faults minimum will be there. Our expectation. What is the probability that a sheet 5 meter by 8 meter will have at most one fault? At most one fault means maximum one only can come. After that 2 faults, 3 faults, there is no chance. Means it is a very nice sheet, very excellent sheet. So here lambda is equal to 4 and P of X is equal to R is our formula. lambda to the power r into e power minus r lambda by r factorial. So p of x less than or equal to 1 means only two cases. P of x is equal to 0 we have to find, P of x is equal to 1 we have to find and add them. They are coming as e to the power minus 4 plus 4 e to the power minus 4. It is 5 times e to the power minus 4. It is from tables 0.0916. So means it is very good sheet. We can judge it as it is an excellent sheet. Almost there are no faults. Let us see one more sum. Suppose vehicles arrive at a signalized road intersection at an average rate of 360 per hour. Per minute you have to find, divided by 60, then 6 per minute. And the cycle of the traffic lights is set at 40 seconds. That time duration set at traffic signals, that time duration set at 40 seconds. In what percentage of cycles will the number of vehicles arriving be? Exactly 5, less than 5. Exactly 5 means what? P of x is equal to 5 you have to find. Less than 5 means what? P of x less than 5 you have to find. If after the lights change to green, there is time to clear only 5 vehicles before the signal changes to red again, what is the probability that waiting vehicles are not cleared in one cycle? Here, let us try to understand. In 40 seconds, we expect 4 vehicles. So, that's why lambda is equal to 4. Now, let us find one by one. P of exactly 5 means P of x is equal to 5. That is coming as nearly 15.6% of cycles. Now, less than 5 means P of x less than 5 means we can use exponential formula also. Same this, e power minus lambda into 1 plus lambda to the power 4 plus lambda square by 2 factorial plus lambda cube by 3 factorial plus lambda 4 by 4 factorial, exponential formula. So it is coming as 0.6288. So vehicles will not be cleared if more than 5 are waiting. So P of greater than 5 is nothing but 1 minus P of exactly 5 minus P of less than 5. Just technique. All these values known to us, subtract, it is coming 0.2148. That's why we have to make the sum easier, simpler to bring the answer quickly. Like that, if 250 liters of water are known to be polluted with 106 bacteria, what is the probability that a sample of 1 cubic centimeter, 1 cc means 1 cubic centimeter. Actually, in physics also we know quantitatively 1 cc is equal to 1 ml cubic centimeter, or it is a centimeter cube. All are quantitatively equal. 1 cubic centimeter is equal to 1 cubic centimeter, 1 cc, 1 milliliter is for liquids. 1 milliliter for liquids. 1 cubic centimeter, it is for solids. 1 cc, it is for gases. So, matter will be in 3 stages: solids, liquids, gases. In all 3, in our mathematics, if you take a smallest measure quantitatively, that is cc or ml or centimeter cube. So, all the volumetrically, quantitatively, all these 3 are equal. So in CC, in 1 cc, we expect 4 bacteria, means 10 power 6 by 20 by 2,50,000. So since lambda is equal to 4. So no bacteria means P of x is equal to 0, we have to find. No bacteria means P of x is equal to 0, we have to find. It is 0.0183 using our formula. Now let us see a book containing 150 pages. It has 100 misprints. Find the probability that a particular page contains no mistakes. Other question, 5 misprints. One more question, at least 2 misprints. At least 2 misprints means P of x less than or equal to, P of x greater than or equal to 2, we have to find. And more than 1 misprint means P of x greater than or equal to 1, we have to find. So by reading the sum only, we have to analyze what is given there, what we have to find. Here P of defective is clearly it is given there, 0.02. So Poisson approximation to binomial, lambda is equal to n into p formula. N is 100, p is 0.02, it is lambda value is coming as 2. Now where P of probability of 4 or fewer defectives in a sample of 100 is 5 chances are there. P of x is equal to 0, plus P of x is equal to 1, plus P of x is equal to 2, plus P of x is equal to 3, plus P of x is equal to 4. All these values comes like this, and its value is 0.947347. Now let us keep it in a expectation cost formula. Inspection costs C, P of x is equal to C. Those values for C is equal to 75, P of x is equal to C is 0.947347. If cost is 75 into 50, P of x is equal to C is 0.05 into 26. Now estimation cost is equal to product of the sum of the product of these two tables, 75 into 0.947347 plus 75 into 50 into 0.0526. It is 268.5 pages. So like that we can analyze all these things in a proper way. Now let us do some recapitulation. Till now we have found how to do sums simpler using Poisson distribution, using binomial distribution. In a binomial distribution, whenever number of trials are correctly known and success possibility is known to you, then only you can be able to apply binomial distribution. But what is the advantage of Poisson distribution? Even though these two values are not known, if you are able to find the success rate, then very easily and within less steps than of binomial distribution, we can find the correct answer and a very accurate answer than binomial distribution. That is the significance of Poisson distribution. So in Poisson distribution, we can find the required probability of the given event more accurate than binomial distribution. That is the noteworthy point. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.